Okay, so it's complete. Now I'm going to open using this result. Go to data source, add. Okay, so let's find our SR3 here. So Horwell, great. Now let's see the reservoir. Focus on the Horwells first. All right, you can see this, horizontal well, and that hopefully it's going to be interesting. All right, let's go to display, gas saturation. We only change the configuration of the well. We maintain everything, including the injection rate. So let's see what happens. All right, interesting. We might as well change it to this. All right, water mole fraction. All right, water mass density. Okay, all right, so that's it. We can also, you know, compare the result from both. So let's put it on dashboard. Okay, I'm going to delete that, put it on dashboard, and put it also there. All right. So on the left, we have the vertical well. On the right, we have the horizontal well. Okay, let's check the water mole fraction for CO2. And let's just click on this, play controls, so you can see the difference, right? And yeah, because the volume of the injection, the CO2 injection rate and water injection rate is exactly the same. So I think what's the difference is only, it's not big. It's not a big difference. But I don't know. Let's say if we check on just to make sure you capture everything here, you get the message. You can also switch to water mass density. This, right? Okay. So let's see what happens on time series. Special history. First from the vertical well. Let's check the CO2 supercritical. Add to new plot. Compare it with the horizontal well. Okay. So, hmm, you know, vertical well plays better in terms of structural trapping for the CO2 supercritical. But let's see if we talk about the CO2 trap by the residual trapping. So this is for vertical well, and this one form horizontal well. Vertical well performs better. Interesting. And lastly, solubility trapping. So CO2 dissolved from vertical injector there. Oh, it's quite big. And lastly, for the horizontal well. Now, horizontal well plays better in terms of CO2 being dissolved by the brine. You can see the comparison, right? Okay. Let's see if we want to change. If you want, just change the color. Okay. You know, you understand what I mean, right? Okay. Yep. So yeah, once again, maybe we can do it one by one. So in terms of, you know, let's change the plot again. Okay, let's see like this. Okay, so in terms of CO2 being trapped structurally, or we call the parameter CO2 supercritical, but it can also be CO2 gas and or CO2 liquid. But because we are in supercritical phase, now the free phase of CO2 supercritical being trapped by the structural trapping is shown by this parameter. So vertical injector of CO2 plus vertical water injector play beta compared to the horizontal counterpart. But if we talk about, I'm unchecking them, this is for the solubility, no, sorry. This is for the residual trapping for vertical injectors, and this is for the horizontal injectors. Again, the the vertical injectors win. But if you compare the residual, no, solubility trapping, horizontal well now play beta. Okay? So yeah, that's it. But this is just a simulation, right? In real life, when you put horizontal well on, on the stage, you know, if you set them as the injector of interest to be executed, then you will gain improvement in terms of, well, longevity, well, productivity, you know, horizontal well, you know, plays better compared to vertical well in terms of injectivity or productivity. But of course, it will come with a price. Horizontal well is much or significantly more expensive than the vertical counterpart. Okay. But yeah, we are just, doing exercise, simulation study, so it doesn't hurt. So yeah, this is the thing that we can do to compare the performance of vertical injector and horizontal injector. And in this case, we combine the CO2 injection with water injection. If you want to know the detail about combining CO2 injection and water injection, you can check on my playlist for CO2 sequestration modeling. Okay, so I think that's all, and see you again in the next CO2 sequestration modeling videos. Thank you.